Hello once again, dear learners. You are welcome to GCL Tutorials, the best platform where social studies is taught in a simple way where you can perform and become the best student in class and at the same time out there as an excellent student. Alright, so we've been treating a series of something on significance of some natural features of the earth, and I'm bringing you another session or episode of the lesson we have been treating so far. We looked at the structure of the earth the other time, where we saw the layers of the earth. So the innermost part, inner core, outer core, we moved to the mantle, and then we got to the crust, the outermost part of the earth. Good. Now, when we're describing the outer core, we did mention something concerning magma. Now, magma is found in the outer core, so we actually see the outer core or view it or describe that part of the earth or that layer of the earth as liquid. Okay, but the inner core is solid because it contains substances like nickel and iron. Now, the heat within the earth, okay, so that part of the earth, the heat within is very intense. Take note also that the heat we are also experiencing or receiving from the sun, or the sun's energy alone, is also another power to cause these layers, okay, to undergo what we call tectonic movement. Now, not just that, under rotation and revolution, because the earth is revolving around the sun, it needs a lot of force, okay? And that force is actually being driven or influenced or determined by the energy of the sun. Because the sun in the middle of the solar system, the planet, is able to cause all these planets to drag around it and move around it, okay? Now, as that is going on, the force and that pressure alongside the heat cause the innermost part, which are soft. We're talking about the layers. The layers of the earth can also be referred to as what? Plates. Plates. Now, these plates move as the rotation and revolution is going on. Now, as the layers of the earth move, the pressure can cause them to open up or tear up or separate or fold up. Now, as this is happening, because these layers are down there, the inner part, and they are soft, whatever happens here, any deformity that takes place here will affect the crust. Let's take this typical example, a description. I use a pregnant woman. When a woman conceives, the baby develops through several stages. So as the baby is developing, you have, it doesn't take just a month or two for you to see the stomach taking shape, okay, or you see the belly of the woman, okay. Now, what is happening here is that the womb is actually carrying the baby, and whatever fetus, embryo, zygote, or whatever nature it is going to develop. And they are going to scan and see that, okay, there is a baby there. Now, as it is developing, it is increasing in size, and for that matter, it has to affect the nature of the body. And so, in due time, you begin to see the belly coming out or protruding, okay? Then you know this is a clear pregnancy. Well, aside that, we can use other examples, but that's a typical example. So what I'm trying to demonstrate here is that the layers of the earth, as they move, or the plates of the earth as they move, they actually affect the surface of the crust where we live and conduct our activities. And when this happens, they begin to create what we call landforms on the surface of the earth. They create landforms on the surface of the earth. Now, these landforms could be in the form of hills, mountains, valleys, and so on and so forth. So we are going to focus on one part of it, major one, which is mountain. Okay, mountain. So we look at that. So this is resulting as a result of the is resulting from the movement of the plates or the layers of the earth. So when that happens, we call that concept tectonic movement. Tectonic movement. In some concepts, they also refer to as a plate tectonic. Plate tectonic. So there is a drift, there is a movement of the layers of the earth shifting under us, but we don't see it. The only thing we begin to see is that landforms are being created. Now, it doesn't take a whole, just a year or two for these landforms to be created. But some are radical. They just appear and they get formed, and we'll get into that. So we pick one way or one type of mountain. We look at the 5 basic types of mountains. So we are going to pick them in series, and we'll take one now. But before we look at that particular one, we will define mountain first. So let's define mountain and know what you are supposed to write if you are asked to describe mountain. So when we talk about mountains, so just a simple definition. Mountains can be described as physical elevations of landform. Above sea level. The sea is considered as the lowest part of the earth because by geologists or geographers. So we measure every mountain using the sea level as a basis, okay, or the benchmark. Now, when you take a mountain like Mountain Everest, Mountain Kilimanjaro, Sierra Leone mountains, the one in Ghana, Mountain Afaja, Turubani, Afebaji, and so on and so forth. All these are mountains, okay? They have heights and they are usually measured in meters. So we know for that. We can give examples here, but for now, you just need to know that this is how you can simply describe mountains. All right. So there are 5 basic types of mountains. Okay, so if you are okay with this, then we'll move to the 5 basic types. We'll be looking at the 5 basic types of mountains. And we'll take how one of them, key one, is formed. Okay, so 5 basic types of mountains. We'll look at volcanic mountains, fold mountains, fault or block mountains, plateau mountains. Then we'll take dome mountains. Dome mountains actually have something similar to do with volcanic mountains. It's through the eruption of a volcano, but just that the eruption does not appear on the surface, okay, but it actually affects the crust and takes a shape that has a round top. And when that happens, we call that mountain a dome mountain. But when it breaks the surface and appears at the top, showing exposing the lava. Okay, then the lava now becomes hardened or solidified after it is exposed to atmosphere or the air and the sun, water, rain, and so on and so forth. Then it becomes a volcanic mountain. I hope you got the 5 types. So we'll take them one by one. In this particular episode, we'll look at the volcanic mountains. Okay, so let's quickly go into that. Okay, for volcanic mountain, the result, take note of this. The result mainly are out of volcanic eruptions, the volcanic eruptions. Now, where this is originating from is the outer core. So we have magma, molten magma in the outer core. So those particles down there, the elements, the iron and nickel and other substances that have melted together with the soil or rocks or whatever there have become liquefied. Okay, they are in the liquid state, and as they continue to burn because they are hot and they are melting other substances, they are moving down there, deep down there. And you know, liquid will always find a space to penetrate or just move through or pass. Now, what is happening there is that if any weak layer is exposed, or the magma, the flowing magma down there comes across any weak layer, it will definitely break through, melt, and then force itself up because it's a burning fire altogether and very hot temperature, very, very high temperature. Okay, that's talking about the magma. So this is what is actually happening. If we want to get a pictorial view, so we take this part, the crust. We know it's not 100% plain, so that is how come I have drawn it this way. So you don't draw a straight line and call it a crust. So this is my crust. Then we can have some other layers right here. So down here, I will try and locate the presence of magma here. The presence of magma in this area. So the region of the outer core, what is happening? So as the magma keeps flowing, it penetrates through a weak layer or some weak layers. It could be different parts, can create parts for itself because it has so much heat that as it keeps boiling and melting the layers of the earth, it has to get a space to erupt. So erupt is using the force to come out at once. So it creates this space for itself. The space that it creates, or the path through which the magma travels and appears on the surface of the earth, is called the vent. The vent, just like a hole. So it will now pass through this side, the vent, and then boom, to appear, to erupt and get to the surface of the earth. Yeah, so the mountain will begin to take its shape because the amount of magma that pours on the surface will determine the shape of the mountain. So if it continuously pours, then it will keep piling up on the surface here. When it appears on the surface, we don't call it magma anymore. So I'm labeling this as my molten magma. This becomes a molten magma passing through a vent and then appearing on the surface of the crust. So when it appears on the surface of the crust, we will call it lava. It becomes lava. We call it lava, but it is within the surface of the earth. Down there, it is magma. Okay, so now we have the lava. This lava now solidifies. So solidified lava. Now, the exit of that on the surface of the crust, the exit or any part of it that the magma is able to penetrate through and pour out as lava, that hole or that exit point is called a crater. It's called a crater. So we have a crater over there. That is the mouth or the exit point of the magma. Then it pours on the surface. So this now becomes our volcanic mountain. Yeah. So we now have our volcanic mountain. So that is the passing through the vent. You can have it. Then it takes a shape like this. We take a shape of a cone. Yeah, a cone in that nature. So beautiful. You should be able to sketch this and then describe how a volcanic mountain. Okay, so you start by saying that a volcanic mountain occurs as a result of a volcanic eruption. Okay, now when molten magma hits part of a weak layer or weaker layers down below the crust, it appears on the surface of the crust, okay, as lava. The lava which is exposed to the atmosphere or other conditions around it becomes solidified. And when it becomes solidified, what happens? It forms the volcanic mountain. Now, final thing before we end this session. As the magma is flowing, mind you that it gets to a point whereby maybe the force doesn't push it enough to totally or completely appear on the surface. Some remain in these mountains or just in the surface or just below the surface of the crust. And when that happens, it is definitely going to solidify. Mind you, there is water under the crust. And so possibly some part of this can be created. Okay, so if a path is created for that water, it can pass through the mountain and flow, okay, and become a waterfall or what we call a spring. Okay, so we have that already. Now, the magma that stays just within the surface of the earth, or just below the surface of the earth, or within the mountain itself and solidifies and becomes rock, we refer to them as intrusive because they are formed within. So the intrusive, okay, these are intrusive. So because they are rocks, they are just rocks, but when you break them with a dynamite, you break this mountain with a dynamite, you obtain rocks. So we call them intrusive igneous rocks. So take note, igneous rocks are mainly generated from volcanic mountains. They are mainly gotten from, and that's why they are so hard, because this is coming from the innermost part of what? The interior part of the earth, and it's appearing on the surface. So possibly we could have very hard rock, okay, very hard rock. So those ones become the intrusive one, the ones that stay within and do not appear. The ones that appear on the surface that we can just see with our physical eye, they become the extrusive igneous rock. So extrusive, the magma that appears as lava and solidifies and becomes rock, those ones will become extrusive igneous rock. So igneous spelled is extrusive So extrusive, outside, on the surface, intrusive, inside, in the surface, in or within the surface, So this is a brief information that or description that you can have on volcanic mountains. I believe this has been helpful and you can make a very good description out of this and a good sketch too as well. That is one of the qualities of a good social studies student. You should be able to sketch, you should be able to draw as much as possible, and let your description fall in line or be in line with the illustration or the diagram that you use to support your explanation. Okay, I believe we've been able to talk about this. In the next section, we'll look at another mountain which is not formed as a result of volcanic mountain, but rather through the folding of the earth layers. So, learners, thanks for your time watching me here. Still GCL tutorials. Share, like, comment. If there is any question, put it in the comment section. Touch the notification bell if you are watching this video for the first time, and keep watching GCL tutorials. For now, I'll say bye. See you again.